So hello everyone, in this video we will solve another LeetCode problem, and the problem name is range product queries of powers. It is medium rated and the problem number is 2438. So let us read the problem statement first. So you are given a positive integer n. There exists a zero indexed array called powers composed of minimum number of powers of 2 that sum up to n. The array is sorted in non-decreasing order. That means it is sorted in increasing order. And there is only one way to form the array. You are also given a zero index 2D integer array called queries, where query of I denotes left of I, comma right of I. Now for each query of I represents a query where you have to find product of all the powers of j, where j lies between left of I to right of I. We'll understand the question with the help of an example because the problem statement is a little bit long. But yeah, for now continue reading. And in the end we need to return an array answers equal to length of queries, where answer of I is the answer to the particular ith query. And since the answer can go very large, since we need to do product operations, so we just need to take mod after taking each and every product. So this is the problem statement. So let us understand with the help of the first example what the question mean to say and try to find some solution out of it. So this is the first example where n is given as 15 and this is the corresponding queries array. Now let us understand what the question is saying. So here in this question where n is given to as 15, first the question is saying there is a power array such that the power array consists of powers of 2. So powers of 2, not n, let us take some other variable. So there may be many powers of 2. Now these powers of 2, the summation of these should sum up to n. Now how it is possible? So let us take this n equal to 15 only. So when n equal to 15, how can we generate a power array such that the corresponding sum results in 15? So in that case, our power array would look something like this. 1, obviously because it is an odd number, so 1 will be there. 2, 4 and 8. 1, 2, 4 and 8 is the power array. Now 8 plus 4 is 12. 12 plus 2 is 14, 14 plus 1 is 15. So by taking summation of all the powers of 2, we are getting n equal to 15 here. So this is the correct power array, and since the question is also saying there can be only one power array possible, so we have generated the power array. But the question is, how will we actually generate in terms of code? Now it is also very simple. Let me just show you. Now whenever there is a question related to powers of 2, you should come up with the only one thing in mind, that is binary representation. Whenever there is question related to powers of 2, your first thought process should be in the terms of binary representation. So let us think in terms of that. So n is given as 15. So what is the binary representation? Its binary representation would be 1, 1, 1 and 1. Now what does these binary presentation actually means? So these are nothing but the powers of 2 only, right? This is 2 to the power 0, this is 2 to the power 1, this is 2 to the power 2 and this is 2 to the power 3, and these are nothing but value 1, value 4, value 2 and value 8. So can you understand one thing here? The binary representation is in itself giving us the power array. It is as simple as that. We just need to take what bit is set and take power of that. Take power of 2 comma the set bit. Here I is the set bit. So this is how first we will generate the power array. So this was the first part of the question, generating the power array. Now what does the second part of the question says? Now the second part of the question is also very simple. Rather it is more simpler than this, the first part. The only part to think about in this question was to generate the power array that we have already done. We will dry run on this entire example also, but first let us understand the entire question very clearly. Now the second part of the question says is the queries of I. Now this queries of I represents the index that are present in power array. So first of all, what was the power array? Power array was 1, 2, 4 and 8. Now this is the index 0, 1, 2 and 3. Now for each query of I, we need to take product of all the index values that are present in this power within range 0, within range like queries of I comma 0 and queries of I comma 1. So what is queries of I comma 0 in this first case? It is 0. And what is queries of I comma 1? It is 1. So first we will take the product of all the values that are present in this power array from 0 to 1 index. So at 0 value is 1 and at index 1 the value is 2. So we will take the product, we will get product as 2. So you can also see in this explanation as well, for the first query the result we are getting is 2. Now for the second query, that is 2 comma 2, since there is only one index, because 2 comma 2 there is only one unique index, so we will take the product as that particular value itself. So for the second query we get the power as the product as 4. For the third query, that is 0 comma 3, we need to take product of like 0th index, 1th index and second index and the third index. So 0th index we have 1, first index we have 2, second index we have 4 and at the third index we have 8. So what is the product? So 4 into 8 is 32, 32 into 2 is 64 and 64 into 1 is 64 only. So for the third query we have answer as 64 and you can also see in the explanation part as well. So this is how what the question is actually meaning, and in the end we just need to store all the results of this query in some answer and just return that. So for the query 1 we were getting answer as 2, for query 2 we were getting answer as 4 and for the query 3 or rather at index 2 we were getting answer as 64. So we will return answer 2 comma 4 comma 64 and this is what our actual output is. So let us take some other example and try to dry run on that. So let us do the dry run part now. So this is the example that I have taken where n value is 21 and this is the corresponding queries array. Now first, what was the first step? First step was to generate the powers array. Now how will we generate the powers array? With the help of the binary representation. So first we will get the binary representation. So here's the binary representation of 21 would look like 1 0 1 0 1. Now this would represent 2 to the power 0, this would represent 2 to the power 1, this would represent 2 to the power 2, this would represent 2 to the power 3 and this would represent 2 to the power 4. So our power array would look something like this. What all are the set bits? Set bit is 2 to the power 0. So first, sorry for that. So first it will be 1. Then what is the next set bit? 2 to the power 2. So 4. And what is the next set bit? It is 2 to the power 4. So that is 16. So this will be our corresponding power array. Now what was the next step? The next step is simpler. Just iterate on this query and get the corresponding result and store in our answer. So this is our answer array where we'll be storing the products. So query of 0 comma 1, that means we need to take product of 1 cross 4. So 1 cross 4 is nothing but 4 only, so we'll be storing 4. What is the next part? Next part is 1 comma 2. So 1 comma 2 means, that means 4 multiplied by 16. Now 4 multiplied by 16 is 64. So we'll store the 64 in our answer vector. Now here we are taking very small integers, but the product might go very long, so we need to take product in long. So in that case we need to return the answer, this answer array in integers. So we will take modulo, where this modulo will be nothing but 1e9 plus 7. So this will we will take care in the code. So this is the answer that we will be returning in the end. So this was the dry run part. So I hope you understand this question. in more better way now. So let us see the code now. So this is the code. So first I have declared a mod which is nothing but 29 plus 7. Then I have declared one power vector and answer vector. Now first of all, what we were doing, we were taking the binary representation and taking the set bits 2 to the power of that particular set bits and so storing it in our power vector. So similarly here what we are doing, for all the bits from 0 to 32, we are just checking by n and 1 shift to I. Now this is what, this is just checking if the corresponding ith bit is set or not, is set or not. If it is set, that means we need to take 2 to the power of that particular set bit and store it in a power vector. So this is what we are doing, we are just pushing the 2 to the power of that corresponding set bit and storing it in a power vector. Then what we need to do, we just need to take the products of all the corresponding queries of I. So for query of I, we are taking L and R, where L and R is the range from for the particular query of I. Then for that particular L to R, we are just taking all the numbers and taking product of that. And as we have also discussed in the dry run part, we need to take mod since answer can go into long as well. So we are just taking the mod, and in the end whatever product we are getting for the ith query, we are just storing it in our answer, and in the end we are just returning this answer. So this was the solution for this problem. So I hope you understand this problem. Thank you for watching.